Hello and welcome. My name is Mr. Kish. I am the teacher for EDD, or Engineering, Design and Development. Quick glance at what EDD looks like. It is a class of invention and design and creation. It is a senior capstone course for our students who are hopefully going on to pursue engineering or highly technical careers in college. Okay, so as I said, it is a senior capstone course. Our students have taken at least 2 of the other Project Lead the Way courses in our Project Lead the Way group. Some other hands-on classes are also encouraged, woods, metals, auto, small engines, things of those nature as well. So what class looks like, a quick rundown here. Essentially, at the beginning of class, we are doing a quick review of skills that students have learned over the years in some of the Project Lead the Way and other technical classes. We start with a quick CAD review. We also do a little bit of electrical and programming review, just to kind of refresh the students. Some of them might have taken the intro class as a freshman, and so it's been quite a few years. And so it's nice to kind of just revitalize those skills as they will be needing them throughout this class. In general, the students work in teams. We select year-long technical design projects. These projects typically culminate in a contest that is either state or nationwide, or they will culminate in some type of a product demonstration for a specific client, where the client is then going to, render their approval, of the student's work. Students will also be learning to manage a team, manage budgets and timelines and deadlines. Most of the contests have a very specific date. They often involve reports and things like that that have to be submitted ahead of time. For our class, I usually tell the students what they kind of have to work with financial-wise. They are also able to, fundraise and get outside investors or mentors to help out with some of the projects as well. It's also a great way to get them to work with some other professional engineers and designers and kind of get that experience of working with someone who does this professionally. Students will essentially be designing the project as the team to meet the very specific goal of the competition or their clients' wishes. And then hopefully we will take them to actual competition. Sometimes they're in the state, sometimes we have to travel, and students get to compete against other students from around the country and see how their designs stack up. A big focus of the class is really getting to work as a team. For most students, this will be the largest and longest project that they will ever have worked on, where there's actually money involved and other people. Prior to this, probably a large history project or something like that went for 2 weeks or so was probably the largest project they've seen. So this is a really great experience for them, especially as they're moving on to college. And they're going to be faced with some very large, design projects at engineering school, and they're going to have a really great feel for how to manage a team, how to keep people on task and doing stuff, and how to work within the, financial parameters that they're given and the design parameters that they're given. In addition, students will be testing designs, redesigning things, and creating technical reports and other types of documentation throughout the course to kind of show their progress and towards their goals. There's a quick glance at some of the competitions that we've done in the past. So on the left here, we have the NASA Moon rover, or now I believe it's called the Mars rover. It's a human pedal-powered vehicle. We actually had a few students compete in that a couple years ago down in Alabama. In the center here, we have the Electrothon. We've been competing in this one for, I'd say, about 12 to 13 years now. This is a student-driven, battery-powered electric vehicle. We race these up at Lime Rock, Connecticut here, and it's also a national competition. Here we have some former HK students on the right-hand side with our MATE ROV underwater robot. This is a competition that's put on in conjunction with the Coast Guard, where students had to design an underwater remotely controlled robot that will perform tasks mimicking real-world situations underwater. In the lower center here, we have the TARC, Team America Rocketry Contest, where students have to design a rocket to hit a certain height and time requirement that changes each year. It also has to carry a payload, typically of some eggs. The competition changes every year and really forces students to launch many, many times, collect data, and then be able to make predictions and hit a new target on the day of the competition based upon their knowledge of the rocket and how it functions. Really exciting competition. And on the far left here, we have the AUVSI drone competition. We call the drone, although I think other teams are also able to submit radio-controlled planes. Essentially, we are designing a remotely controlled aircraft that will fly both via remote control and autonomously with a pre-program to carry out some type of a mission. Typically is to drop a payload at a certain location using GPS, and then also to do some surveilling, take photographs along the way, and pick up on and decipher images on the ground, typically shapes and letters and things of that nature. So there's a bit of programming as well as the design of the actual drone itself. Speaking of design, just a quick glance at some of the types of design students doing. So we have a lot of CAD work that gets done. This allows us to utilize items that are printed on the 3D printer. We also have some technical drawings for assembly and construction and reporting out. On the lower right-hand corner here, you can see a very specific program for designing and simulating the rocketry contest. So students get a taste for all different types of design software. Here we can see some prototype fabrication. These are a couple of images a few years ago from our first attempt at a fiberglass bodied race car. Students are involved in a vacuum bagging process where they researched, purchased the supplies necessary, and then with the guidance of some mentors, set up for a very large molding project that results in the vehicle that you can see on the right. We have some electrical work that involves wiring, soldering, designing, reading schematics, and sometimes programming as well to make control devices and control circuits. We make great use of our 3D printers in class as well. These are used to generate parts rather quickly, sometimes for prototyping, but oftentimes they are actually the part of the actual robot or the project that we're designing. It's a nice, quick and easy way for the students to see their designs come to real life and actually live and function on a project. Some examples of some actual testing that happens. Sometimes some individual parts are tested. You can see in the left-hand picture here, students are actually force testing a landing gear mount. They're collecting some data about the force that it can withstand and verifying that it's going to be able to do its job. On the right-hand side here, you can see some pictures of a rocket in takeoff and in recovery. Again, testing a lot of these designs is a major part of the class. Collecting data and then analyzing that data and making decisions based off that information, also a big part of class. Here we can also see some other forms of testing. So students are here doing a tethered flight test to verify motor function. On the right here, we can see some CAD simulation of a part strength. This part will ultimately be machined out of aluminum. So before we go ahead and start cutting into some expensive pieces, we want to verify that it's going to do the job that it was intended to do. And so, throughout class, the students will kind of dive in and out of these different roles. Each team member will have multiple jobs throughout class, and they kind of cycle as the project evolves. Like I said, it's a great experience for them really to have to think about and plan out the group work, work as a team, decide who's going to do what, and hold each other responsible for taking care of their individual tasks and goals. And here's just a quick look at the grading breakdown of class. So about 30% of the class focuses on our engineering notebook. So students will be keeping a daily log of their project work in class. This will involve, daily thoughts and notes. It also involves documentation of designs, tests, to-dos, and things of that nature. Students should be entering daily. The document has to be dated and numbered. In the engineering world, the engineering notebook is actually a legal document that is often brought to court for copyright and other types of legal affairs. About 10% of the class is formal lab reports. There typically is a midterm and a final that where the students kind of write a formalized engineering or scientific report about something specific in their project that they've been working on. And about 50% of the class is the actual in-class lab time, design, and prototyping time. This is where the students are actually getting their hands dirty. They're drawing on the computer. They're wiring things up. They're building things. They're testing things. Every day is kind of different and, exciting, I think, for them and for me to see what's going to happen next. About 10% is what I call out-of-class / homework. While there's not any specific formalized homework that's assigned, like other classes, there's no real worksheets to fill out. It is expected that students will need to devote some time, perhaps during lunch or after school, to kind of meet certain timelines. So if they can't get it done within the class time, they need to plan to come in during lunch or after school or work at home to hit their marks so that the team can continue to kind of flourish throughout class. And that's really the gist of class. Thanks for watching. Feel free to contact me via email or have your student contact me through Google Classroom if you have questions or concerns. And I hope we have a great year. Thanks.